Well, good morning,
Yeah.
ladies and gentlemen. Let me welcome you on today's roundtable hosted by Ericsson. And especially thank you that you found some time to join us today. My name is Vito Horak, and I'll be the moderator today morning. Maybe very few words about the process today. We have about 30 minutes for the presentations of our speakers. And then we will, of course, get some time to answer your questions, approximately something between 10 and 15 minutes. What is also important, I would ask you to put your questions to the chat, so in written form, and we'll be happy to answer all of them if we have enough time, and we will just read and answer them after the presentations. Our topic today is 5G networks in industry and manufacturing, and we have two renowned speakers from Ericsson with us today. Cveto Gašperut, who is the head of Ericsson in Czech Republic, and Sebastian Elmgren, who is Smart Manufacturing Portfolio Manager at Ericsson. I don't want to steal some time from the speakers, so I will right now hand over to Cveto and ask him to present his part of the presentation.
Thank you, Vito, and thank you everybody for joining this roundtable or presentation which we are about to do with Sebastian. So my name is Cveto Gašperut. I'm heading here the Ericsson in Czech Republic, and Ericsson in Czech Republic is we have quite some history. I think we saw that we established the branch office almost 110 years ago here in Prague, but in this form that we are today, we are existing here since 1995, so wholly owned by Ericsson Group. Of course, we are the provider of the technology and services to the telecom operators, and we basically are selling and delivering our portfolio, complete portfolio, to the major customers, major operators here in Czech Republic, which you can see. That should be enough for the introduction. Today's topic, which we chose, is about 5G potential in Czech Republic, with a special focus on, let's say, manufacturing and automotive industry. So let me do a quick introduction why this topic is chosen, and then I will give word to Sebastian, who is the expert in this, from the working on the Ericsson global level with many customers. So he will go into the details, but the reason why on one side 5G is so, I mean, hot topic right now, is that it seems that this technology is really ramping up all around the world. Here it's some data how specific technologies, let's say, reached 1 billion of users in time. So we can see that it took 74 years to have 1 billion credit card users around the world. And then just at the bottom, you can see that 5G seems to go into this direction, that 1 billion users will be reached in 3.5 years. So, which is, I would say, now the first implementation started 2 years ago in the United States and Korea. And so we would see, let's say, in the end of 2022, already 1 billion users using this. Of course, also live networks are popping up, and I think there are currently some 140 live networks, out of which Ericsson is how to say, part of the 79 of them. We have around 127 commercial contracts so far. So we think we are a major player in this, and also in Czech Republic, we are working with the customers on this. The reason why we chose today to talk about the let's say 5G in manufacturing and automotive is twofold. One is, of course, you know, the Czech Republic is heavily industrialized country, and actually the World Bank says that almost 38% of the Czech GDP comes from the industry. So it's looking from the Central and Eastern European countries, the country with the most, with the highest percentage coming from the industry. And then on top of this, the reason why we chose smart production is to talk about smart production today is that Ericsson, together with some other companies like Qualcomm, initiated research with analytics firm called Analysys Mason about the benefits of 5G beyond, let's say, consumer benefits like mobile broadband and I don't know, high-speed data connection on the phone. So this research looked into what parts of the let's say, which verticals 5G could contribute the most from the benefits perspective. And they made the research in the 4 areas. So smart urban, which is smart cities, this type of use cases, then smart public services, smart production, which is Industry 4.0 and manufacturing, and then smart rural. And here it's about smart agriculture, but also fixed wireless access in the rural areas, in, let's say, white spot areas. And actually for Czech Republic, which is highly industrialized country, the biggest benefits are actually coming from the smart production, from this Industry 4.0. So the Analysys Mason estimated that the net benefit by the end of the 2025 could be up to close to 100 million. So the difference between the benefits and the cost to invest it. So we are talking about 130 Czech crowns of benefits with approximate investment of 33 billion Czech crowns overall for this all 4 use cases. And for the smart production, which is the biggest share, we are talking about potentially close to 60 billion Czech crowns with the investment of something below 20 billion Czech crowns. So that's why we think the reason to choose today to talk about Industry 4.0 and the use of 5G in it is very, how to say, it's the right choice. Without too much going into the further, let's say, economical details, I will give my word to Sebastian now to talk about some specific use cases and technical things about such Industry 4.0 use cases. And they are mainly based on the dedicated networks which are built for the factories. And just my last word, I mean, we are not only talking about this and doing with other customers, we are also walking the talk. This means that we are actually using in our factories 5G already today for helping us, helping our teams and our people to deliver efficiently and with high quality. So the last use case which we did is newly built factory for base stations in the United States. And that one uses 5G for smart factory use cases, some of them which Sebastian will talk about right now in the moment.
Thank you very much, Cveto. So I will take over the control of the presentation here. A second. So I hope you can see my presentation now. So Sebastian Elmgren is my name. I'm located in Stockholm, and as you heard, I'm driving the manufacturing vertical within Ericsson for 4G and 5G applications for the industry. So just a bit of a background on how we are looking at this. This is a quite new area for Ericsson. We started maybe 3 years ago. And we started to look what value we could bring to the industry. Looking at a typical factory, what we saw was on the shop floor, there's a lot of smart equipment, robots, AGVs, sensors, and other equipment. And then on the higher levels, on the application layer, there's also a lot of smart applications from different vendors. But really the connection between those two worlds had a bit more to wish for. Today, 98% of all connectivity in a factory is with cables. They are stable and secure, but they are not really flexible enough for the need of Industry 4.0, where flexibility is one of the driving forces. So there is clearly a need for wireless communication. We saw a lot of industries starting to investigate this, and often they turn to Wi-Fi, which was the technology they knew since before, and that gave the flexibility, but maybe didn't have the security and stability needed for the industrial use cases. So that's where Ericsson has seen it, that we can bring something to the table and create value for the industry. And we are doing that with what we call dedicated networks. So dedicated networks is basically a private 4G or 5G network now inside a factory. So this is what a typical deployment could look like. We have all the equipment on-prem. You have your own network with your own SIM cards, creating a secure, stable, and high-performing communication inside your factory. So this is the foundation for Ericsson offering in this area. And this is where we think we can bring flexibility, stability, and high performance for the communication in a factory. But it's not only about performance here, it's also to simplify for an enterprise, because these networks is not only for high performance applications. We can cover a wider range of use cases with the same infrastructure. Everything from small sensors, connected tools, video applications, AR, remote operations, moving into more need for low latency, all the way up to real-time industrial protocols covered with the same network, the same infrastructure. Where you previously would need maybe a Zigbee network, a Bluetooth network, a cable network, a Wi-Fi network, and so on. We can simplify a lot with having this adaptable network, being able to address a wide range of use cases. But we're not doing this all by ourselves. Of course, the network is only a part of this. We need to have an ecosystem around this to be able to provide end-to-end applications to the industry. And we are doing that with our partner program, where we are partnering up with different actors that have pieces of the puzzle to create the full solution. So we work with device partners, making sure that there are gateways that can be retrofitted onto equipment that work with the network, module vendors to be able to implement in industrial equipment modules for 4G and 5G communications, software vendors to make sure we have applications that can take care of all this data. We have OEMs, and that's equipment manufacturers from the industry that we work with to make sure that the next generation of industrial equipment is 5G native. And we also have system integrators that are the ones that can put all these pieces together. So this is an ever-growing ecosystem that we are working very tightly with to make sure that we can offer the industry the best possible solution together. So I'm going to go into some examples and some reference cases to show you a bit on what's happening in this area and how our industry is using this technology today. So one of the reference cases that we have is the Mercedes-Benz factory in Germany, together with Telefonica. So in general, the automotive industry is the driving force behind this change. They have the most advanced production systems. They are using connectivity in the most advanced way and are pushing the technology to its limits. So they are really the ones taking lead in this. And by doing that, they're also starting to put pressure on their suppliers to follow in that direction and also adopt the 5G technology. So it's really interesting to follow what's happening in the car industry. And one of the examples of following what's happening in the car industry is Atlas Copco, who is a provider of power tools that are broadly useful in the car industries. These are screwdrivers, which is a critical part in the process. And as they see that the car manufacturers are investing in these kind of networks, they are also then following and starting to implement 5G modules into their tools to be able to provide use cases into the end user's factory. So they are now developing 4G and 5G enabled tools on Ericsson's infrastructure to provide advanced assembly systems to their customers in this, really opening up for a lot of interesting use cases, adding this technology. And these are really advanced screwdrivers with a lot of different sensors and quality critical part of the assembly of a car. So it's not the screwdriver that you buy in your local shop, and adding 5G here opens up for even more advanced uses of these screwdrivers. Another common use case here that we see is when it comes to AGVs, these small automatic guided vehicles that moves around, taking care of the internal logistics of a factory. Especially when it comes to the online retailers, big warehouses, we see huge installations of AGVs moving around, taking care of all the orders that's coming in and the logistics. And here, 5G is really showing its potential as being very good at handling moving equipment inside a factory and high density. So there's a lot of this application now being moved from older radio technologies up to 5G to provide the performance in these large installations. And also the industry is following here, delivering components on the shop floor to wherever they are needed. And one of the applications that are working tightly with these AGVs and having components delivered is, of course, the robotic cells. So that's another way of using 5G here. And even if these robots are not constantly moving around in any factory, there is a constant need for optimization, adding robots, taking away, moving them a bit, constantly following the ups and downs in volumes and product mixes. And here, taking away the cables for the robots is a significantly improvement in flexibility for the production. And we are working with a number of different robot manufacturers. In this case, it's Comau, Italian robot manufacturer, also a big supplier to the car industry, to have this wireless robots that can improve the flexibility of the factory. But in the factory, it's not only robots, there is also a lot of workers. And one of the trends that we are seeing is the augmentation of the workers using AR. So this is an example from our own factory in Estonia. We have a big factory in Tallinn where we are using AR technology for troubleshooting of boards. So whenever a board fails, it needs to be troubleshooted. And previously, there was a lot of different data sources that were needed for the operator to handle. Now we use AR technology to overlay all of that information into the same view. And by doing that, the worker can work concentrated on his task, and we reduce the troubleshooting time with 50% just by reducing the mental shifts between the different data sources. So I think this is an excellent case to show that the AR is actually creating value and not only is some cool stuff to show off. It can be used in a very good way to augment the workers. Another popular case is to take the smart metering concept into the factory, to start to use the low latency performance of the 5G network to take care of energy management. So this can be done in different steps. The first step is just to introduce the smart meters on the 5G network in a factory to have a higher granularity when it comes to your energy consumption, to be able to look on the individual machines, how they consume electricity, and also use the low latency to on sub-second level monitor how the energy is being used for those individual machines. That can give a lot of insights on what is causing high energy consumption? Where could you save? How could you optimize, and so on? But then you can take this to the next level. If you, for example, have parts of your processes which are using ovens or big freezers, process steps that have kind of a buffer capacity, where you could actually turn off the energy for a couple of seconds without losing the temperature. Then you can use that to balance your network to avoid peaks in energy consumption. Those peaks are what's very costly for any factory, the peaking consumption. So if you can flatten out your energy consumption, there is a lot to win. But then you need a reliable network with low latency to be able to control on that level. So a lot of money to save that. And once you have that capability, then you can actually connect that to the national grid and become a virtual power plant. So if there is a peaking consumption on a national level, you can then sell back, not consuming electricity for a couple of seconds and balance the big network. That is becoming more and more popular now as we're introducing renewable energy sources like solar and wind power, which do fluctuate a bit and needs these kind of functions to balance. A use case that has been very popular now in Corona time is to be able to reduce traveling with AR technology. So this is a way of using AR technology to have an expert see what you see on the shop floor. So that could be a service technician in another country who can give expert advice to the local service engineer on the shop floor, seeing what he's seeing and then showing the engineer what to do. Very efficient. It could also be a designer of a product, and there's a problem in the production of that product, and he can give advice on how to improve the quality or how to fix a product in production. So great potential to reduce the traveling cost, and this is of course not only important now in Corona times, but also moving on to lower our carbon footprint and avoid traveling if not necessary. Another important area that we see a lot of companies investing in is, of course, the worker safety. So here we have solutions that are being used where we use vision systems to identify workers and how they are dressed. So if they are moving into an area where you need a hard hat, for example, the video system will recognize if correct hard hat is being worn, and if not, there will be an alarm to make sure that people are dressed in the correct way and supporting worker safety. There is also a trend when it comes to wearables like smart watches and so on to be used for worker safety. As more and more automation is being introduced, we see that there is a need for those kind of applications. You can have a smart watch with an alarm button. So if something goes wrong, you can push that, and immediately there will be an emergency call connected to somebody that can help you. Also using sensors to see if there is a fall or an accident, and then have an automatic alarm. So those kind of applications we see a lot of growth in. This will also later on be combined with the capability of a 5G network to position. So we can have kind of an indoor positioning system, making sure that whenever an alarm is risen from one of those devices, it can be tracked and then help can come even faster. So that was a quick view of what's happening and what kind of use cases we see in this area. So there is a huge growth both when it comes to use cases and also the ecosystem. More and more companies join this. So this is a really exciting area that I'm happy to work with. So that was my last slide, and I think we should open up for some questions now.
Cool. So thank you for the presentations, Sebastian and Cveto. We got a lot of questions, so thank you for the introductory material that you gave us. And I will just now tally the questions in order as they came. We have a question from Rockland24. So how many 5G networks do you expect you will reach till the end of the year 2021 globally? Right, this is a very difficult question, but we got another one which is very similar. So when you think, what's your guess, when will Czech industry be fully or mainly 5G enabled? Maybe this is a question that could go to Cveto, I think.
Yeah, I mean, to answer the first part, I would say everything that is so far contracted, and I think I was talking about 127 contracts from Ericsson, that should be up and running by the end of the 2021. So we will move from 79 to at least 130, how to say, live networks. But it's very difficult for me to judge how many, let's say, these consumer networks will be out. I mean, we are having around 400 operators around the world. I guess we could see half of those at least having 5G in the commercial operation. When it comes to the, let's say, such dedicated networks, which we talked about today with Sebastian, the potential is much bigger. As you can see that we are talking about covering specific sites for specific manufacturing use cases. And I would say that in Czech Republic, there is potential for at least 30 of such dedicated networks when we are talking about manufacturing sites. But to be honest, I don't think that we will see 30 of them by the end of 2021, also not by the end of 2022. But I would say that we definitely will see first ones popping up in the real commercial operation this year. That is, let's say, answer to these two questions.
Okay, thank you. Very precise, actually. So we got one question from Živě, from Jakub Čížek, probably goes to Sebastian. Why isn't it enough to go with Wi-Fi in a future factory? So what's actually the benefit of 5G instead of Wi-Fi?
Yeah, I mean, Wi-Fi will play a role, and these technologies would coexist. But we do see that for the more critical applications, 5G will have an advantage. And the basic reason for that is that 5G is working on what we call licensed spectrum, but Wi-Fi is on unlicensed. So there are pros and cons with the different approaches here, but unlicensed is basically you don't need any permission to transmit there, but on the licensed spectrum you need to have permission to transmit. So it's more simple on an unlicensed side, but on the other hand, you need to take everybody else into consideration because everybody can transmit on those frequencies. So there are certain rules that you need to follow if you transmit on the unlicensed spectrum. And one of those is what we call listen before talk. And that means before you transmit, you need to listen and make sure that nobody else is using that channel right now. And if there is some traffic, you need to wait and then listen again and see if the area is free. And then repeat until you get a slot where you can transmit. And that means that if it's very few devices in a network, then you can have really good performance. But as soon as you start to add more devices there, it's kind of uncoordinated. So the performance goes down and the reliability, the variation of the performance is quite significant. You can have 1 millisecond delay in 1 second, and then the next second you have 500 milliseconds. And a lot of industrial use cases can't accept that variation in performance. So even if average looks good, the variation is causing a problem. On the other hand, if you look at the licensed technology, then you know that you are the only one who is allowed to transmit there. So then you can schedule all communication instead. And the network will give every device a time slot when to listen and when to transmit. And by having this coordination, you can have a high reliability and a good performance even on the high load of the network. So the variation if on the performance is very, very small. So you know what you get and you have this high reliability networks. So that's in short how we see the differences, but they will of course coexist.
Okay, thank you, Sebastian. Another important question is: does Ericsson implement the 5G in the manufacturing by themselves or with partners? And if Ericsson provides all necessary equipment, for smart factory infrastructure ecosystem?
Maybe I can answer that. Yeah. So you saw in most of the cases which Sebastian presented, there was also a partner named from the operator side. So our strategy is that in I would say 90% of the cases, we are approaching the enterprises through our operator partners. So you saw the Mercedes-Benz with Telefonica, you saw the Comau Robotics with TIM. So there is always operator partner in place who is, let's say, working with us and is actually priming towards the enterprise. There are some specific cases where industry spectrum is available for the end customers, like in Germany, where not only operators could acquire the 5G spectrum, but also some industrial entities. And in that case, Ericsson is sometimes considering to go directly, but I don't, since in Czech Republic there is no industry spectrum allocated, I don't see that Ericsson will go directly to any industrial customer here in Czech Republic.
Okay, thank you, Cveto. One question for Sebastian. So which of the cases that you presented is, in your opinion, the most revolutionary thing for the manufacturing industry? So.
Well, it's a bit hard to predict what will be the most revolutionary. I think, the flexible robots to have that kind of flexibility in manufacturing will be very, very revolutionary, where you can move into a one-piece flow in your factory, where you have the flexibility to every product that you're producing is unique in some way without driving up the cost. And that's this mass customization that is happening now. We're not seeing that's revolutionary right now today, but I think in the long term that will be a very significant change. Looking at revolutionary parts right now, I think that energy management is something that can create real value here today and be quite revolutionary in supporting the change to more renewable energy sources.
Maybe I forgot to answer the second part of the question from the previous question about if Ericsson can provide whole solution for these industrial things. As Sebastian showed, we are building an ecosystem for this. So from the Ericsson perspective, we have, let's say, two things. One is the complete network infrastructure, which we are providing. So both the core networks, the radio networks, some transmission as well if it's needed. And at the same time, what we do have is some, let's say, industrial knowledge from the teams which, like Sebastian, are working on the global scale. So we have a special dedicated business unit who is working with dedicated networks, and they are really having industry-specific knowledge which they can share in these engagements. On top of this, we also have something called Center of Excellence, which is based in Aachen and is actually available for our customers to go there and do some proof of concepts and, let's say, some minimum viable products that they can test out, and then this could be brought into the real environment. When it comes to the other things, like, Ericsson is not producing modems or units that are used instead of the phone, so modem. And here we are partnering with different companies, and I think the ecosystem which shows with many partners is I would say, equally important for the success, both our, but also the end customer success, that they have the wide range of possibilities to choose from.
Thank you, Cveto. Important question. What is the real difference between 4G and 5G for the industrial use cases?
Yeah, so I would say, I mean, 5G is really opening up a new world of performance. So that will give us the low latency that we see in the most advanced use cases, and also the extended bandwidth. So that is guaranteeing that this would be a technology that will fulfill the industry's needs for many years to come. Looking at the use cases today, a lot of these things can be done and are being done on 4G, and that is often a good way to start and then evolve into 5G. But 5G is really taking this to the next level and supporting the next generation of use cases here.
Okay, thank you. Another question, I think this is last on my list for now. How long can a typical implementation in a factory take? I mean, this is a very scalable thing, of course, but if you probably could name some typical example or a time frame.
Yes, I mean, we have done smaller installations in a day. So these are quite simple to install. I would say, I mean, covering a bit larger factory, putting cables for the radio dots, as we call them, our radio heads, is probably what takes the longest time, but definitely less than a week for installing this. So it's not a big installation time here.
Okay.
I mean, the whole project will take longer than a week, but let's say the actual technical implementation can be done in a week or two to have first results. But you know, I mean, I would say from the contract till the contract signature till the actual implementation, to get this all the materials and everything, 3 months is, let's say, standard time. But from this, you maybe have 2 weeks actual installation once everything is designed and how to say, ready for the physical installation.
Okay, thank you. I have no more question right now on my list. So I think we are actually close to our time. So just to encourage you who could join today, please send us your questions via email, or let's keep in touch about this topic. And I wanted especially to thank the speakers for today's presentations, and also for the input during the Q&A session. Thanks to the journalists who could join today. We will definitely also send you some press materials about this topic and keep in touch with you. So thank you for your time again, and let's stay connected. Thank you.
Yeah, thank you everybody, and thank for very good questions. And as you see, we have some key takeaways here. That I mean, 5G is happening now. This is really a significant opportunity for the Czech Republic, and it's actually creating value now for manufacturing with increased flexibility and efficiency. So this is a super exciting area to work with right now. Thank you, everybody.
Thank you, everybody.
Thanks for zooming up.
Have a good day.
Thanks. Bye-bye.